What does this list have to do with math class? If you're like me, this is how you might have experienced math as a student, and I think it still shows up in our teaching and our school structures. These aren't necessarily bad, like I have a sense of urgency at the beginning of math class so that I talk less and students have more time to solve problems, but they can be a little bit problematic. According to the researchers who compiled this list, the characteristics listed here are damaging because they are used as norms and standards without being proactively named or chosen by the group. This is from the White Supremacy Culture Characteristics List, which you can find at this link. And this isn't about making white people feel bad. This is about examining what culture do we default to when we gather together as human beings. And if we default to this list without considering other options, then we're prioritizing one culture over another, or we're seeing one culture as more supreme than the others. So how does this come up in math class? Well, here's directions from a curriculum that is widely used in the United States. Draw an area model and then solve using the standard algorithm. Use arrows to match the partial products from the area model to the partial products of the algorithm. And in this case, students are all expected to solve in this one way, and this is the right way for that lesson. But what about a student who solves in a different way or is in a different place in their mathematical journey, and they have some agency, and they want to solve this problem like this? They say, well, okay, 12 23s, that's what this looks like on my paper. And I know that 2 23s is 46, and I can repeat that over and over and over. And from there, I can say, well, I basically have 6 times 46, but I rather do 6 times 40 is 240, and 6 times 6 is 36. And then I want to add those together. I know the goal of these directions was to give kids an understanding of partial products, the standard algorithm, how to use area models, but we can do that without removing kids' agency and still giving many different perspectives. What if we took this student's work and we compared and contrasted it with an area model broken apart by place value using the standard algorithm? Now we can see that although this student decided to add two groups of 23 before they broke the numbers apart, they're still using partial products when they break up the 46 into 40 and 6. So now I ask you, how might our math class support cultural diversity? How do we make sure that we're balancing out the different cultures that our students are bringing, and we're examining what counts as normal or what we default to?